Students, let us see how to write the complementary function depending upon the type of the roots. So, we all know there are three types of roots. The first one is real and distinct. And second root is real and coincident. And the third root is complex root. So, based on these three types of root, we are going to write the complementary function. So, please remember, if the roots are real and distinct, let us denote it. M1 and M2 are the two roots, and let me write M1 and M2 are two distinct roots. Suppose only two roots I am considering. And then if the roots are real and they are same, so meaning of coincident is what? Same. So I'll denote it as M1 is equals to M2. Here I write M1 not equal to M2. They are real but distinct. Case 1. Real but same. Case 2. And the case 3 is complex root. So here we denote the complex root by P plus QI, where P is known as real part and Q is known as imaginary part. So it is very important, first of all, to find the roots and then based on the type of the root to write the complementary function. So if this basic concept is clear to all, so you can tackle all the problems based on this module easily. So whole module is depending on this basic concept. So let us consider some of the roots and try to learn how to write the complementary function. So please remember, I am telling you about how to write the complementary function. We are discussing about how to write the complementary function depending upon the three different types of root. First is real and distinct. Second is real and coincident. And third is complex root. So let us consider some of the example. I'll consider, let m1 equals to 2 and m2 equals to 3. These are the two roots which are real and distinct. So if the roots are real and distinct, then the complementary function, which is denoted as yc, or it is also written as complementary function cf. So for this we write the solution, that is complementary function, as c1 into e raised to m1x plus c2 e raised to m2x. So substitute the value of m1 as 2 and m2 equals to 3. So this will give you the solution. Yc is c1 into e raised to 2x plus c2 into e raised to 3x. So this is how to write complementary function if your root is real and distinct. Let us consider second example where the roots are given as 1, minus 1, 2, minus 2. So totally how many roots are there? There are 4 roots. All are different. So I write they are real and they are distinct. So, so if the roots are real and distinct, let us write the complementary function yc as c1 e raised to first root 1x plus c2 e raised to second root minus 1x plus c3 e raised to third root 2x plus c4 e raised to the fourth root minus 2x. So it's very simple. So you should identify whether the root is real and different and real and coincident. Now consider another example. If the roots are 3 and 3. So what do you say about this? Whether they are real? Yes, they are real. Are they different or they are same? They are same. Therefore, the roots are real and same. That is, they are coincident. So, in this case, we write the complementary function as c1 plus c2 multiply a variable x and then e raised to mx. So, here we consider m1 equals to m2, both are equals to 3. So, we write e raised to mx, that is c1 plus c2x into e raised to 3x. Now let me consider one more example. The roots are 0, minus 2, minus 2, minus 2. So there are totally 4 roots in which one of the root is 0 and remaining 3 roots are minus 2. So this minus 2 is repeated for 3 times. So in this type, we write the first root is real and other roots are real but they are same. So in this case, we write the complementary function as c1 into e raised to mx, first root m value 0x, plus now since remaining roots are same, we write it as c2 plus c3 multiply x plus c4 multiply x square and then into e raised to mx, where m will take now the value minus 2 and x. I hope this is clear. Okay. Now let me consider another example. If the root you are obtaining after simplification as plus or minus 2i. So it implies in the form of p plus or minus qi, where the real part p we consider it as 0 and the imaginary part q is equals to 2. So in this case, the complementary function is generally written as e raised to px. So it is which type of root? It is known as a complex root. This is known as a complex root where real part is 0. So e raised to px into c1 cos qx plus c2 sin qx. So in this you substitute the value of p as 0 and q equals to 2. So this will give us e raised to p is 0 into x, c1 cos q value is 2x plus c2 sin 2x, and we all know e raised to 0 is equals to 1. Therefore 0 into x is 0, e raised to 0 will be equals to 1. So we write yc is equals to 1 c1 cos 2x plus c2 sin 2x. Okay. So this is solution if the root is complex. Let me consider one more example. if the root is in the form of 1, 1, 1 plus or minus I. So, totally here also there are 4 roots in which 1 is repeated for twice, and here 1 plus I, 1 minus I are the other two roots. Therefore, in this case, how to write the complementary function yc? So, since 1 is repeated for twice, we write the complementary function as c1 plus c2x into e raised to 1x. M value is 1 plus the second one in 1 plus or minus I. What is value of p? P is 1 and q is also equals to 1. Therefore, we add here e raised to value of p, as we have seen in the previous example, px, we are going to write e raised to px. So e raised to value of p is 1, so e raised to 1x into c1 cos q value is 1, so 1x plus c2 sin 1x. Yes, is it clear? So I can write it as what? c1 plus c2x into e raised to x plus e raised to x. So as we have considered c1 and c2 already, so let us write here as c3 and c4. Okay, so the final solution will be c1 plus c2x e raised to x plus e raised to 1x, I have written as x, and c3 cos x plus c4 sin x. So, dear friends, if you are this much perfect to write the complementary function, then half of the work is done. So, please try to learn, go through all the examples given in this video, and try to write a complementary function which will help you to solve all the example in this module.